Okay, this is the hint for the PSAT NMSQT Fall 2016 test. Calculator allowed, problem number 29. So I've set this up a little differently than what the problem looks like, but I will give you some hints on what it's looking for in the problem. So first of all, you have a really complicated equation here, and you want to simplify it as much as possible by distributing and combining like terms. So if we distribute through the parentheses over here, we get 2n squared plus 4n minus 100 equals, and then I've got to distribute negative n here, so negative n squared minus 5n plus 20. So none of these terms can combine on the left side or on the right side. But we could move some things around so that it's all on one side. This looks like it's going to be a quadratic. We've got some squared variables in here. So we want to make the whole thing equal 0. So we're trying to get it to equal 0 down here so that we can solve it. So I would add n squared to both sides, which will give me 3n squared. I'm going to add 5n to both sides, which gives me 9n. And then I'd subtract this 20, which will give me negative 120, and then this equals 0. There are several ways to solve quadratics. The way that I'm going to show you on here is to use factoring and the zero product property. Generally, it's faster than using the quadratic formula or completing the squares, so that's what we're going to do. First, I notice all of the coefficients and the constant, they're all divisible by 3, so let's take a 3 out of all those terms. So that would leave me with n squared plus 3n minus 40. So it's like dividing everything by 3, except that the 3 is still sitting out here. It hasn't actually gone away. And then we can factor this part further into two groups by using the X puzzles that we learned when we did our factoring unit. So we're looking for numbers that multiply to make negative 40 and that add to make 3. So we're looking for a negative and a positive to multiply to make negative 40. So I'm going to use 8 and negative 5. They multiply to make negative 40. They add to make 3. And so I would have n plus 8 and n minus 5 in here. And how this helps us is using the zero product property. 3 times this number is 0, which means something in here has to equal 0. So we take n plus 8, make it equal to 0, and n minus 5, make it equal to 0. And so if we subtract 8 here, we'll get negative 8. If you add 5 here, you get n equals 5. So if they were asking you for the solutions or for one of the solutions, this is what you would get. Now on the actual test question, it asks you for the positive difference between the two answers. So let me talk about what that means. So the positive difference is what it actually asks for on that PSAT question. So the positive difference and the negative difference basically would look like this. Either I'm going to take negative 8 minus 5. It's going to give me a negative difference. I'm going to take 5 minus negative 8. That'll give me the positive difference. This would give me negative 13. This is going to give me positive 13. So they're looking for the one that is positive. So essentially what we did, just to kind of review, is we turned this into a quadratic equation. And with any kind of equation, you want to distribute, combine like terms, get everything to one side. It's just going to make it easier to solve. And then using factoring is just a simple way to solve this. Another thing that you can do that is fairly straightforward if you're just looking for the solutions is to use a graph. So let me go back up here to the original equation that I had, and we'll put this into the calculator. So if you hit the y equals key like this, I'm going to zoom in just a little bit further, we can put this and this in as two different equations and see where they cross. Now the calculator will use x instead of n, but it's basically the same thing. So I do 2x parentheses x plus 2 close parentheses minus 100. That was the left side of my original equation. And then negative x, parentheses, x plus 5, close parentheses, plus 20. That was the right-hand side of my equation. And then we're going to see where these cross. And sometimes you have to play with the window a little bit and see everything, but we'll see what we can see if we just hit graph. So I can see one intersection point over here, and there's another one down here somewhere. So what I might want to do is just zoom out. So I'm going to hit zoom out, and then when you get back to the screen, it's looking for where you want to zoom out. I'll just zoom out from 0, 0. So you hit enter again, and you can see there's a couple of parabolas on my calculator. They're blue and red. See if I can make that show up just a little bit better. And you can see a couple of intersection points right here and right here. And you can use your trace feature and try to estimate where that is. It's not going to be exact for this because I'm zoomed out so far. Or the other thing we could do is we could use the calculate feature, which is above your trace key. If you hit second and the trace key, you can actually tell it to find where the graphs intersect. And so for first curve, I hit enter, second curve, enter, guess, enter, and that's going to give us this point over here, -8, -4. And so -8 is the x that we're looking for. We don't really care about that y value, so -8 is one of our solutions. And then you have to come a little further over here to find the other one. So I moved my cursor using the arrow keys, do second and calc again, find the intersection. Oh, sorry, I guess we have to do the intersection first. So I'm going to put my cursor a little closer to where this intersection is on the right-hand side over here. And then when it says first curve, I hit enter, second curve, enter, guess, enter, and it will give me the 5 where they intersect. This is a little cumbersome if you're not going to remember exactly what to do, but it is a way that you could check by using your calculator. Just figure out where the two sides of the equation intersect, and your solutions are the x value.